we may have been given our best chance of finding alien life outside our solar system. A rocky planet that may harbor life has been discovered just 4 light-years from Earth, close enough to be reached by future space missions. The planet, dubbed a second Earth, is the right distance from its star to host liquid water, which means it has the potential for alien life. It is the closest exoplanet we could ever discover, and experts say missions to the planet to search for signs of life could be feasible within our lifetime. Astronomers have found clear evidence that our nearest star, Proxima Centauri, is the Sun to another Earth-like world. The group of researchers, using the European Southern Observatory telescopes, have named the exciting world Proxima b. Thousands of exoplanets have been discovered before, but unlike the others, this planet is within our reach. While 4 light-years is a long way, more than 25 trillion miles, future generations of super-fast spacecraft could conceivably travel to the planet within the next few decades. Much further in the future the planet may even be colonized by space travelers from Earth. One possible obstacle to life evolving and flourishing on the planet is the way it hugs its parent star. Proxima b is only 4.6 million miles from the star, 5% of the distance between the Earth and the Sun, and takes just 11.2 days to complete one orbit. It is around 1.3 times as massive as Earth. But because Proxima Centauri is a dim red dwarf star radiating much less heat than the Sun, it still occupies the habitable zone where temperatures are mild enough to permit liquid surface water. The temperature on the surface of the planet could be between -90 degrees and 30 degrees Celsius. On the other hand, the planet is blasted by powerful ultraviolet rays and X-rays from the star. Any life that evolved on its surface would have to be hardened against the radiation. But the prospect of finding life on Proxima b has excited scientists. Many exoplanets have been found and many more will be found, but searching for the closest potential Earth analog and succeeding has been the experience of a lifetime for all of us, Dr. Guillaume Anglada-Escude, lead author of the paper, said. Many people's stories and efforts have converged on this discovery. The result is also a tribute to all of them. The search for life on Proxima b comes next. 2 separate papers have been published today, describing the habitability of Proxima b and its climate. The papers find the existence of liquid water on the planet today cannot be ruled out. This means water may be present over the surface of the planet. But it would only be in the sunniest regions, either in an area in the hemisphere of the planet facing the star. The way Proxima b rotates, strong radiation from its star and the formation history of the planet makes its climate quite different from that of the Earth. It is unlikely that Proxima b has seasons. But if liquid water does exist on the planet, it could mean alien life might thrive there. If this is the case, we could discover it within decades, experts have said. A team called Pale Red Dot is behind the discovery, which includes researchers from the University of Hertfordshire, Queen Mary University of London, the Instituto de Astrofísica de Andalucía in Granada, Spain and the University of Göttingen in Germany, among others. The researchers used the high-accuracy radial velocity Planet Searcher, an instrument on the European Southern Observatory's 3.6-meter La Silla telescope in Chile's Atacama Desert. The telescope measured light from Proxima, the fingerprints that reveal what the star is made of. Small shifts in the frequency of the starlight can be used to work out tiny movements of the star in response to an orbiting planet's gravitational pull. The first hints of a possible planet were spotted back in 2013, but the detection was not convincing, said Dr. Anglada-Escude. Since then we have worked hard to get further observations off the ground with help from ESO and others. The recent Pale Red Dot campaign has been about 2 years in the planning. The Pale Red Dot data, when combined with earlier observations made at ESO observatories and elsewhere, revealed the clear signal of an exciting result. At times Proxima Centauri is approaching Earth at about 3 miles per hour and at times it is receding at the same speed. This pattern of changing velocities repeats with a period of 11.2 days, meaning that is how long it takes to orbit its Sun. Careful analysis of the tiny light shifts showed the planet has a mass at least 1.3 times that of the Earth, orbiting about 4.3 million miles from Proxima Centauri. Some questions about whether life could exist are left unanswered, however. If Proxima b has an atmosphere and if there is water there, and these are big ifs, it is intriguing to think that the simple ingredients, water, carbon dioxide, and rock, that are needed for the formation of biochemical cycles that we call life, could all be present and interacting on the planet's surface, said Dr. Mikko Tuomi, from the Centre for Astrophysical Research at the University of Hertfordshire. But we do not really know. We need to study this system a lot more over the coming decades in order to be able to start answering such questions. However, it is a great place to start looking for life outside the solar system, and it is a very exciting discovery. It certainly seems possible that we could find something out of this world within our lifetime, said Martin Archer, space plasma physicist, Queen Mary University of London, writing for The Conversation. At least some additional information about the environmental conditions on Proxima Centauri b should come sooner rather than later, the researchers say. Now that the planet has been detected, there is an opportunity for follow-up observations. A possible detection of life, or at least of conditions suggestive of the presence of life, is likely to be decades off, but these observations provide opportunities to learn about a planet around the most common type of star in our galaxy, with lessons that are interesting in their own right, for astronomers seeking a systematic understanding of planet formation in our home galaxy.